Thank you for joining us for our webinar, Optimized Telecommunications Network Planning with Mapbox Movement Data. We're real excited to sort of discuss this topic with you, show you a demo, talk about movement data in general, and how we can apply this to a telecommunications use case. So thank you for being patient, and I'm going to officially kick things off here. So first, I want to introduce you to the Mapbox team who's going to present today. And then we will give you an intro to movement data as well as Mapbox boundaries. We do want to talk about why you want to use movement data and boundaries, specifically from Mapbox and how you can apply that to the telco use case. And then we're going to give a live demo, probably the most interesting portion of the session, so you can really see this in action. Finally, we want to do a Q&A. With that, I do want to introduce you to the team. So today we're going to be hearing from Kieran McCann, who is an account manager for the telco space here at Mapbox and also a go-to-market expert for telco. And you can see Kieran's email address there as well, but I will show this similar slide at the end of the session where you can get in touch. We're also going to hear from Megan White, who's going to do the demo portion. Megan is a telco solutions architect. There's her email. And then myself, I'm in product marketing. I'm just hosting the session, but I really rely on Kieran and Megan, who are our telco experts here. So with that, I'm going to pass it over to Kieran, and we're going to really get started.
All right, thanks everyone, and nice to be here today. Excited to talk about the telco space and the movement product and how this can really kind of enhance some of the current work that you're all doing today at your business. So this first slide is really talking about, the importance of outages and how these can really be a make or break for the telco space these days. So there's a lot of stats on the page here, but the emphasis here is that, if you don't have reliable coverage, if you don't have coverage that customers can depend on, this is one of the main reasons why people switch carriers or drop service or, customers churn, right? So outages are front and center for a lot of telcos when they're thinking about their business today and thinking about improving their service over time. So we want to reduce outages, obviously, as much as we can. But when outages do occur, which is inevitable with any network, we want to make sure that we can prioritize those and appropriately respond as quickly as possible. So 44% of operators experience 10 big outages per year at least. And then even more minor outages that occur at kind of the local level, right? 43% of businesses say that, connectivity problems for IoT can cause life-affecting changes to staff and users. There's a lot of services today that are dependent on networks to, help people in life or death situations. Outside of life and death, there's just a lot of you depend on these networks for going about your day-to-day life, and having any type of outage can be a major issue. But in some cases, that can actually have a huge impact on someone's livelihood, right? 90% of businesses have lost sales or customers as the direct result of an outage. Pretty much every telco has customers that will drop the service based on some outage that has consistently been a problem or impacted them at a critical point in time, right? And then 11% will switch to another provider because of this. That's the main reason we hear from our customers is why people have either switched to them because of some major outage or some long-standing connectivity problem in a certain area. That's why they've switched. And then out of the switches that happen, most of them are citing the reason is, hey, I had better network quality or I had more consistent, reliable coverage from the carrier that I ended up moving to. And then the dollar amount here is pretty staggering. Just the amount of money and the amount of capital that's invested by telcos into improving coverage and improving outages and fixing those, whether that be a tactical fix or a long-term investment fix. It's $20 billion a year, and that's probably a low number when you look at the kind of wide, broad amount of work that goes into just general network improvement to, prevent this from happening. So there's really two types of network improvements. There's tactical fixes that happen when you're actually going out there and deploying assets to make a fix in real time. And then there's long-term investment, which is, 3 to 5 year time horizon where you're thinking about improving coverage, improving the network, improving signal quality. And those are kind of both something that we think about when it comes to how to improve service. So next slide, Greg. So we're here to talk today about Mapbox Movement, which is a data set that we provide, and there's a annual license. You can get this in your Mapbox account. You can use this with any of your existing data models today. But what Mapbox Movement is a living, breathing data set, which is pretty unique. It's built from an aggregated, anonymized location source, basically a pipeline that we have from our 700 million monthly active users across our services. So Mapbox has a mobile SDK. Everyone that is using Mapbox in one of their apps or services sends Mapbox telemetry. It's anonymized and aggregated, so there's no personal information here. But we're able to collect basically a living pulse of what's going on in cities and in countries around the world. And that is a really powerful data set that we are able to use that basically allows us to understand what's happening on a block by block basis and how much movement is changing from place to place. So there's really only a few companies in the world that have this breadth and size of activity data from their user base. I think you could probably think about the others, Apple, Google, and then some other carrier or providers. But we have the largest that we're aware of data set that's available for customers to actually purchase and access. So Apple and Google don't share this. They collect this as well, but we are actually making this commercially available. And it's pretty exciting and powerful how much you can do with this. Next slide, Greg. So we already kind of mentioned some of this. Movement data is binned into 100-meter grid tiles. So it's not down to the individual house. It's not down to the individual location where you'd be able to track, individual movement. We really make sure that privacy is a focus here. So we're deliberately not allowing you to go super, super granular, but the 100-meter bins actually are pretty powerful for what you can do to get a sense of what's happening at a citywide level or a block by block level. And there's a lot of use cases that can be pulled from that. There's minimum thresholds here to protect privacy. We're a really privacy focused company, so we don't want to show anything that could be traced back to an individual. So if there's one person walking through a field, we don't actually pick that up in our pipeline. That's scrubbed. There has to be a kind of minimum density that is picked up here for it to actually go into the data set. So we're always thinking about individual users and individual privacy. So that's kind of built into our models here. And then when you're talking about the data set, we have two kind of flavors. There's vehicle only, which actually powers a lot of our traffic models and traffic data sets that we use in our navigation services. And then there's pedestrian only, so you could actually have just taking out the car data, looking at just individuals and humans walking around rather than the car related traffic. We can kind of tell from the speed and the behavior of the usage there that that's either car or human. And then we have different ways to actually aggregate the movement activity by time. So you can do hour by hour insights, you can do day over day, we can do month over month, and you can always compare different timeframes to one another. This will be a historical looking data set, and then also we can provide updates on a regular cadence as well. Great. So this is a global data set. As we said before, we've got users all over the world. That 700 million monthly active user base gives us coverage across everywhere where people are using a Mapbox SDK and Mapbox apps. So our best coverage is going to be where we have the highest user density. That really includes North America, Europe, East Asia, Southeast Asia, Australia. But we have coverage all over the world. It's just going to be those are the kind of prime markets, and that's where we see most of our customers anyway. So if you have questions about that, we can definitely talk to you offline. But this is a global data set, and we really sell this by country. So if you do have a particular need for a specific region, that's sort of how we work out, delivering the data to you. We talked about this a little bit already. This is really just an overview of how the pipeline works and how the data set is created. So, 45,000 different apps are using Mapbox in some way of using our SDK. That 700 million monthly active user base is pushing the telemetry probe data, and we're aggregating that. Over 40 billion daily location events are aggregated in our pipeline. We take that, de-identify anything that would be, below those thresholds, that kind of privacy sweep that occurs, and then we push that through to the two flavors. We can basically identify, is this car, automotive, use cases where people are on the roads, or is this pedestrian, bike, kind of more general movement. So the reason we do that is because different customers have different needs there. There's a lot of folks that just want to know what's going on from a traffic perspective or a roadway perspective. And then there's a lot of other use cases where the pedestrian foot traffic is really the main drive here. You can think about like a retail use case where you want to understand, hey, what does my storefront look like in terms of optimal location? Where should I be putting this so I can get the most kind of pedestrian flows of foot traffic coming by my business? So lots of different ways that you can cut that data and work with it, but those are the kind of two main places. We can also kind of give you an aggregate of both. So if you don't care about kind of dividing those two, we can kind of deliver you a aggregate view. So when we're talking about movement, we already mentioned that it's binned by default by those 100-meter grids. You can then aggregate that information through a couple of different ways by treating the data. In our demo today, we show using this with hex cells, which we know are very important for the way that telcos look at data sets, and that's often how you're binning your data already. So you can aggregate by hex cell. We also have Mapbox boundaries, which is a data set that we also sell, that is basically all the geometries that you would need for different types of geographic boundaries, from the country level down to the state, county, zip codes, neighborhoods. We've got a whole host of different boundaries for the entire globe. So if you wanted to, you could take the movement data here and aggregate that by zip code, and then you get a kind of aggregate score of what the movement activity looks like for any type of geography that you're looking at. So you can use it in the kind of more raw format, which is just the 100-meter bins. You can aggregate it into hexes, or you can aggregate it into boundary geometries and then look at things in detail. Great, next slide. So you may actually already have movement data. We talked to a lot of carriers that they do collect some location telemetry information from their user base, from their plan users, or anyone that's using one of their devices. The limit here is that you have that already, but it's really been to your user base. So if you're carrier A, you're only getting users that are on carrier A. You're not seeing the kind of aggregate activity across the entire population. So you're sort of looking at like a bias sample there. And if you're in an area where you don't have great coverage, or your network is not dominant in that market, you might not be getting the full picture of what's going on in that geography. We also know that, customers of ours, or, folks that are looking at movement patterns and trying to understand just general baselines, they're using census data, which can be a useful tool, and we don't want to replace that. We want to complement it. But as we know, census data is sort of a static look at a moment in time. So you've got 2010, 2020. The 2020 movement census data is, as we know, there's been a lot of changes to life since 2020. I think the 2020 census was, occurring right in the middle of COVID. Since then, we know that, a lot of day-to-day behaviors have changed a lot. So lots of folks are working from home. Lots of folks are no longer going to the office. Folks have moved from cities to, kind of suburbs, or, other markets around the country. So from the telco perspective, that's put a lot of strain on the models that are maybe traditionally very useful and were kind of up to speed of what was going on. But today, the census is not a great accurate look at what the live world looks like. So complementing that with a more up-to-date live look at what's going on with movement patterns is really powerful and can really enhance some of the models that you're looking at rather than just looking at population or demographics. Also, census data doesn't really take into account where people are going outside of their primary residence, right? So we want to understand where are people going when they're going to work, where are they commuting, where are the big kind of choke points of traffic and density of population outside of just where they end up at the end of the day, right? So we think about all of those things, and those are insights that can be unlocked with the movement data set. Next slide. So I already talked a little bit about some of the other use cases. Like I mentioned, the retail analysis. We use this with a lot of our retail customers, as I said, to look at baselines and look at understanding where the optimal site location would be for a retail location, for a business, for any type of real estate use case where you're figuring out location needs. And that was really important coming out of COVID too, where, basically everything reset. We have other use cases here. I won't go into super detailed views of this, but vehicle density, looking at kind of traffic patterns, understanding where you see congestion and where you see kind of patterns emerging there. That's used by municipalities. Lots of automotive companies look at this to understand where they should be kind of prioritizing infrastructure improvements and things like this. Road utilization, kind of similar story there. You're looking at how much of a road is being taxed by, consistent traffic. Where do you maybe need to make improvements to the road or change the traffic patterns there? Trade area analysis. This is like kind of a more economic modeling, looking at, where you could actually improve or understand what's going on with, trade going on in different geographies. And then competitor insights. This is something that is probably interesting for telcos, looking at what the rest of the market's doing, what's going on with patterns of movement with other types of demographics and user bases that you might not have access to. So you could maybe see the movement in aggregate in a market where you're not competitive today, or you're thinking about investing in, and that's something that you could kind of look into for kind of long-term analysis. And then natural disaster situation awareness. If there's a big hurricane or a big natural disaster or wildfire, understanding the movement patterns of folks and trying to understand how to, optimize deployments of emergency responses. That's something that we also work with customers on. So there's kind of no limit to what you can do with the movement data. There's, it's a data set, so it's what you're doing with the data that makes it powerful. But there's so many use cases that we've uncovered over the years with different types of customers. And telco, I think, is another one that we're really, really excited about. So we're going to focus on telco today. So telcos can use movement data in a few different ways. I think what we're going to focus on today, like I said before, is really the tactical focus, which is looking at local outages and looking at local deployments of resources. But there's a few other ways that you could look at this. So the long-term look is like, okay, we have great coverage in these areas. We know what our network looks like, but we're looking at where we want to expand or where we want to add more 5G or where we want to look at broadband coverage or fiber. You can analyze the movement activity of these markets that you're not strong in yet and determine, okay, there's 3 candidate markets. This is the place that's growing the most over the kind of month to month or the year to year look. And you can kind of make investment decisions and bring that data into your modeling to figure out where the best place to deploy capital would be. Obviously, the outage scenario, we're going to talk about that in depth today. But looking at, okay, where's movement, where's there an increase in activity, and where should we actually deploy the fix in terms of triaging those issues where the most people are impacted or the most activity is at a certain point of day. And the movement is going to show you hour by hour how that movement change is happening. So it's going to be different in the middle of the night versus in the middle of the workday, right? So we want to have an understanding of that, and we'll show you that in the demo. And that's where you can kind of think about large scale events like a concert or some kind of big gathering or some kind of big event like a Super Bowl or an NFL game. If there's going to be a tax on the network and the current capacity or like kind of the limit of the ceiling of the network, we want to be able to, maybe deploy additional assets to those areas to improve coverage for kind of a shortened amount of time. We've all been at a concert or a big sports venue when you're leaving and trying to call your Uber or trying to call your family to let them know you're heading out. And maybe the service drops because of that oversaturation of so many people trying to make calls at once. This also occurs in like kind of emergency situations where, maybe there's something where everyone's trying to text their loved ones and explain what's going on. The network is taxed because there's a huge spike of people trying to make calls. So understanding in the moment when those things are happening and understanding how you can maybe deploy assets to, improve the network or, add a little bit of a boost or help people out here, that's really important. And then when it comes to kind of day-to-day stuff, there's towers that need to be just regularly maintained outside of a coverage or an outage situation. You want to know, hey, what is the schedule for these towers being fixed? You might want to actually deploy assets to fix a tower that is newer, but has maybe more of a critical, location for a large amount of people that are in the kind of downtown core, or maybe it's an area where there's a lot of traffic along like a major freeway. You'd want to prioritize those over something that maybe is an older tower that also isn't scheduled to be maintained, but you would prioritize this first. So we have a couple examples of how that could work too. Next slide. So we want to understand a little bit from all of you, and we have a poll here to understand how you, as your organization, thinks about movement data. So we've got a couple questions on the poll here, and we just love to hear from you and the audience what your thoughts are. Feel free to take 30 seconds to a minute to get some responses in here, and then we'll kind of look at the results and talk about it.
Yeah, and just a heads up for everyone, we do have a little swag alert. So if you do participate in the poll, we do randomly pick someone to get a little Mapbox gift, and it's a very nice gift. So do participate.
All
And
right,
we'll just give it about 30 seconds and then we can get the results.
perfect. All right. Do we have the results, Greg? Okay. Looks like from the poll, most of you replied that you don't use movement data yet, but you're interested in looking at the possibilities here. That's pretty interesting. I think that we know that movement data can be powerful, but not everyone has access to the full scale kind of data set that would actually make some of this analysis possible. So that's interesting. And then the next highest response was that you use data to identify areas where you need more coverage, which is sort of more of the strategic investment position rather than the tactical outage perspective, which is interesting too. And I think, as I mentioned before, I think this is very powerful for that long-term investment outlook of where you want to deploy capital, because you can really look at, hey, this is where our network has coverage today, and this is where there's dead zones, and this is how many people we have in the dead zone, and that's where there should be prioritization. So that's totally a use case that we can help you with. It's not the emphasis of our talk today, but we can kind of show you in the data and the demo how that could definitely be possible. So yeah, very cool. A lot of you, put in some other answers, but those were the two biggest responses for sure. Cool. All right.
All
Well,
right.
kind of the overview. Now I'm going to pass it off to Megan. Sorry to cut you off, Megan. But Megan put together this demo, and we're going to kind of walk through the specific use case of the outage scenario, and how movement can be an overlay on the existing kind of data that you would maybe traditionally have already to kind of enhance the scoring and prioritization of the outage scenarios here. Cool. Take it
Cool.
away, Megan.
All right. Yeah. All right. Greg, if you can move to the next slide. So when you're thinking about resolving outages, one factor you're considering, as we've established, is where are the people? And as Kieran talked about, this is important so you can put your resources, your mitigation resources, where they will be having the most impact in terms of customer satisfaction. So today you might be determining the amount of people in an area by using customer connections to your towers along with population data. But since our movement data is a unitless index that tracks patterns of movement, you're able to use it to validate whatever data you're currently using as an indicator. And we deliver this data in a raw format, so you can take a CSV and integrate it with your existing platform or model that you're using to track where people are. So for this demo, our area of interest is San Francisco. And in this first view, we're looking at just the movement data set. Higher amounts of movement are purple and tall, they're extruded, and lower are yellowish beige color. Greg, next slide, please. We can see the movement patterns shifting throughout the city in general. Kieran.
I was just going to say, I think that this kind of shows what we were talking about earlier, where it really is a living, breathing demo. You can see the kind of commute paths and kind of the main freeways increase right around kind of 6 a.m. when people are going into work. You can kind of see 101 and 280 through there, if you're familiar with the Bay Area. And then you can even see like the downtown core, which is like the Market Street area, that starts to pick up. You see people kind of picking up in kind of the residential neighborhoods throughout different parts of the day. But this is the 24-hour slice. So you're going to see at 4 a.m. people are asleep, people start waking up, the whole city starts to breathe, and then there's kind of the exhale when people start going home and going back to those residential areas. So very cool. And this is a kind of snapshot of what that looks like. But when you actually start drilling into the insides, this becomes not just a visualization, but also an analysis tool. So yeah, go ahead, Megan.
Yeah, thanks, Kieran. Yeah. And so by clicking the outage button, the generate outage button, you're generating outages on the fly by creating a random set of points between 50 and 100 within a random radius, random outage generator. And this area is considered an outage cluster because it's experiencing a spike in reports above the baseline. And in this case, I chose 50 as the baseline. I know normally it's like the average of reports. And these reports, the count of reports and the activity index are both binned into H3 grids with resolution 10. I chose this resolution because it most closely matched our 100-meter movement grid, so it was good for the binning process. I also want to note that the style here has changed because we added report counts to the hexagons. Before they didn't have this property. I did a on-the-fly data join with this random generator so that these hexagons now have a property that represents the count of reports within that hexagon. So now the hexagon colors interpolate from yellow to red based on the number of reports within each individual cluster, not within the report entire data set, like the total amount of reports. And I chose to do it on a per cluster basis so that we can identify which towers are likely affected. So you'll find red cluster within, or a red hexagon within each cluster. So you can see where in that cluster the towers are probably affected. And meanwhile, the activity index is now only represented by the hexagon height extrusion, not by color, like in that first slide. So Greg, if you could go to the next slide.
1 sec, Megan, on that piece right there. I think if you go back, Greg. So just to kind of recap, these are, I think it's 6 here. So 6 randomly generated outages. And what we're doing is on the side panel showing the kind of normal without movement data included, how you would prioritize this today, which is really just based on the number of outages, the number of reported outages. And then what we're going to show you is that by adding the movement data, the prioritization on the second column will actually shift based on the activity. So you'll kind of see that in the demo here, but that's like the main emphasis, is that the movement score is actually going to be an overlay on top of what your existing model is. And then it's going to change the prioritization as sort of an additional factor that's taking into account the overall movement score of that that cluster, as Megan described. So
yeah, exactly. And so if, in the next slide, like you'll see the two columns that show us how these outage clusters are prioritized. Column 1 is duplicated in column 2. The only difference between the two columns is that they're reshuffled based on their priority. So in column 1, you'll see the first method that we use for prioritizing the clusters is solely based on the density of reports in the cluster. So this will give us an indication of the scope of impact, since the number of reports will be correlated with how many people are around there experiencing the outage. So I'm just taking the number of reports and dividing it by the area of that cluster. And then the variables I list there, so that you can see like what values I'm using to calculate the density. And then Greg, if you move to the next slide, because it highlights the second column, which Karen mentioned, is there to help you compare the effect that normalization with the move data will have on this prioritization. So I take the exact same density from the first column, and then I normalize it and by multiplying the sum of the activity indexes in the cluster. And this is going to help us get a better picture of where people are at the time of decision making. So when we apply the sum of activity indexes, you can see in the right column that the little boxes will shift up or down according to where people are, the normalized density that we've calculated. And yeah, the UI is a little bit tricky there, but you can compare the color. Hopefully will help you match up the clusters. I use the geocoding API to give these these outages a unique like name that's more human readable. So like mission district, we can see that, vastly changes. This is right now we're considering the movement data at midnight, but it vastly changes from just the density to with the normalized value, moves it much higher up the list.
yeah, and I think the emphasis here is that for different times of day, this is going to shift pretty drastically, because the Mission District's a pretty residential area, so you're going to see more people at home at night. But during the middle of the day, you might see the Mission District is a lot lower priority, because maybe some areas that have higher in-office traffic, people going in and being in the downtown area, is going to be emphasized instead. So but if you were just to look at the density of reported outages, I think that's going to give you sort of a misread or potentially different bias of what's going on with the data, because not everyone reports outages, and maybe only certain people are going to be motivated to do that. But if you're looking at the reported outages plus the kind of general impact to the area, because hey, there's a lot more people in this area now, that's an additional overlay that's going to give you a more precise read of what the prioritization should really be. So this is just an added overlay that's going to give you some more insight into where you should really be maybe deploying assets immediately, or where you should be thinking about making infrastructure changes. Yeah.
Cool. Yeah. So, and to follow that up, when you get this data from us, you have the choice to ask us how you want the data aggregated. You can do it monthly and daily. I chose to do it daily, or I chose to do it hourly, so that we could aggregate the data on a per hour basis and do those comparisons that Kieran was talking about. And I represent that with the time slider, so you're able to shift through the time slider, and the activity index will update and that will update the list so that it reprioritizes the clusters based on the time of day. Because if you have an outage over the weekend, you might pretty steadily receive the same number of reports in a residential area, and a few, 3 popular weekend destinations. And if it were 7 a.m. that you had this pulled up, you would want to focus efforts around the residential neighborhoods where people are most likely are before going out for the day. But if you were looking at similar data around 1 p.m., you would want to prioritize the most popular weekend destination, knowing that most people are usually out and about at that time. And what's cool, you can use the movement data to actually, with those popular weekend destinations, know which ones people are going to most, instead of just being like, yeah, people are here around downtown most of the time. Like, you can use this on a pretty granular level to prioritize based on the most popular destination.
Yeah, and you can see in this view here how much that that second column is really shifting based on the time of the day. So you start at 7 a.m. here, and as that toggles to like the afternoon, you're starting to see a lot of those neighborhoods are switching pretty drastically in terms of the ranking, and that is the difference between maybe getting that right and getting that wrong in terms of where you should be putting out your kind of limited resources to go out and fix an issue. So definitely interesting. And you can see the impact of the movement pretty drastically, actually.
Yeah, you can use the map to compare to use as context for like what's going on. So in this specific example, the ones Noe Valley is pretty close to a highway, or it's like practically a highway, and so those will be pretty active most of the time. But like a popular neighborhood will override that that prioritization based on like what time of the day it is. So I know we've covered that, but in summary, that's what this demo is doing. It's letting you reprioritize based on the hour as well as the activity index in that hour. And that concludes like the gift part. I know we were thinking about maybe just going through a couple of other examples live. I'd be happy. I don't know how we're doing on time, Greg, but I'd be happy to share my screen and we could generate a few more outages and just look at the results in the map together.
Yeah, I'll stop sharing and you can take over and then just give me a heads up when you want me to go back to the slides.
Cool.
Yeah, while Megan's pulling that up, I'll just kind of reemphasize, like, okay, why is this important? I think that the reason this is impactful is that you only have so much bandwidth and resources of making fixes and doing kind of hot fixes in the moment. So if you're choosing what areas to prioritize, you want to make sure you can pick places where most of your customers are and where most of the kind of potential churn mitigation can happen. So if you're maybe just looking at outages as they come in and prioritizing it based on first in, first out, that's kind of maybe the weakest way to do it, because then it's just the whims of time of when they happen, and that's where you're going to deploy assets. The second piece is looking at maybe more data, which maybe, again, you're looking at demographic data and the census stuff, and that's going to give you an additional kind of look at like maybe where you should prioritize. But again, that data is sort of stale. So you're not really getting a live look at what's happening, and you're not getting the kind of sense of, hey, what's going on with the roadways, what's going on with the downtown kind of commutes and things like that. So the third kind of layer deeper, and that's where movement comes in, is you're taking that kind of analysis, but taking it a step further and looking at where people are in real time. And you can use that to make your, deployment decisions for an outage. But like we said before, this could be done at different time scales. So we're talking like hour by hour in like kind of a more live, up-to-date scenario. But you could also look at this in kind of an aggregate view and look at this in the month and say, okay, this is all the outages that are reported. This is where most of the activity is, and this is where we should focus on the month-to-month view, or scan it out a year and say the same thing and say, okay, this is where our network is strong. This is where our network is weak. This is where we should be making investments in maybe, more towers, building out more capacity. So that's like another, time scale to look at this. And outages versus like network improvements are kind of two sides of the same coin. One is more fixing an active issue. The other is kind of preventative measures to make sure that you can build out the network. But yeah, if you had like problems consistently along 101 or 280, that's, hundreds of thousands of people are going to be impacted by that daily. And they might not be able to go and record an outage on their commute if they're driving. So like understanding where you're going to have problem spots and correlating that to hotspots of activity and where your users are on a day-to-day basis is how you can actually improve your network over time and really get some data-driven measures to actually make those improvements rather than sort of using like a hodgepodge of different, maybe incomplete data sets.
And I do want to highlight that the icons that you see are towers that I got from OpenCell ID for a specific provider, and you can see the correlation. I mean, talking about the supply and demand of where coverage is needed and what you currently have for the context of network planning. You can just look at the map. You can see where the trends are and like where the most towers are. I mean, you can see they pretty closely follow the highways where a lot of movement is. But you can imagine you can get even more granular with it and make decisions on where to put new towers based on where the most people are. You're able to style this data however you want that makes sense for you. So you could highlight trends based on the styling of the movement data. Right now it's clear that the highways are, but like I said, you can get even more granular with it. So, all right, I guess with that, we'll generate a couple outages. So here we've got 4 and only the towers within there selected. Like I said, we're elevating the towers so you can kind of see where which towers would be affected. So red and the tower on top of it will be likely the tower that is down or is experiencing issues. And let's see what neighborhood.
Yeah, and the height of the extrusions there is the movements activity for that area, and then again the color is the density of outages. So you see like the orange or red, that means that there's a lot of outages in that cell or reported outages, and then the height of the cell is the movement score for that particular cell. So kind of gives you kind of 2 ways to look at the data. Yeah, just highlighting that.
Yeah, so we're looking at Central Richmond. I think let's see how this one changes. So it stays at the bottom of the list. So at first, if we're looking at just the density of reports, because it's a small area and there's a relatively high number of reports, like you'd think like, oh, okay, that's like we should focus on that first. But when you take into consideration like where it's located, like the area of it actually like falls under. I think this is like a residential area. It's actually pretty low on the list of prioritization because there's more people over here by this crazy highway intersection. And so this is one example of how you can see how they're shifted. And this is at 10 a.m. in the morning. So a lot of people are are out and about. This is for, it specifies here, but I'm not sure if I actually said it, like we're only considering the weekends here. So you can expand the scale with this to include weeks and weekends, but I just wanted to look at the trends on the weekends for this demo.
Yeah, and I think
yeah.
this is a good example because the Richmond district, for those, I mean, I live in San Francisco, so I kind of know the neighborhoods a bit, but the Richmond district is like very residential, a lot of families, a lot of, kind of single family homes. So you're going to see like kind of maybe more people reporting outages because they're at home and they have time to, go on and maybe log into, a kind of reporting system that you have for your carrier, or maybe they have like an app on their phone where they can do that. But the folks that are down on the freeway are driving, so they can't do that. So there's maybe going to be less reported outages, but when you look at the total impact and potential customer churn impact, the folks that are driving on the freeway and the number of kind of pass-throughs of that cell and that cluster, it's actually going to be way higher, but maybe the number of reported outages is lower. So if I was on my commute and making a call or using my maps in the navigation and I lost service, maybe that's a higher impact zone in terms of just the user behavior than somebody that's at home at 10 o'clock on a Saturday. So you want to think about how that behavior and the actual movement and live look at what's going on is maybe more impactful than just the raw reports, because that's kind of what we're showing here. And yeah, I don't know if Megan, if you look at if you kind of slide through the 24 hours, I'd be interested to see how that Richmond district zone, which is kind of the first in the column B, changes, if it changes at all throughout the day.
Yeah, definitely. Here, let's go to it.
So it never really goes above the last slot. Oh, I guess maybe at
In
night.
the second, yeah, here. The one that I was looking at was like which one, like against the freeway, like when like this is more at around like 3, it gets Anza Vista gets reprioritized to the first, and it's in the in the afternoon, early afternoon, and the density of reports is pretty high, and so I think that's why it has a lower activity index, but the activity index is normalizing the density of reports, which are pretty high to begin with, and are higher than the number of reports that are around the freeway. So yeah, you can say it gets pretty blessed from there.
Yeah, so I think this is a good kind of example of this in action. And again, you can kind of see we're doing this with like randomly generated reports, right? But you're going to have your real data, and you're going to be able to use the movement data with real reported outages to kind of compare those instances. And usually there's like a threshold of like, hey, there's this many reported. Now this is kind of a problem spot. Now let's look at it and kind of decide what we want to do in terms of prioritization. So
Yep, cool.
yeah, I think this is good. Doing it on the fly sometimes can be interesting. So we know the neighborhoods and we know kind of the behaviors, but we're speculating on how that would actually play out in action there. So I can touch on this. I think we want to emphasize again that movement data is a really powerful data set. And there's a lot of use cases that can be derived from this. But as we mentioned in the beginning, Mapbox is very, very privacy focused, and we want to just make sure that we kind of tie up the presentation here by saying movement data can be powerful, but it's also important to be responsible in the way that we're generating the movement data here and the way that we create our pipelines. So I just want to say again, we do not collect any information about individual users or anything that can be traced to individuals. But we do have these kind of thresholds and guardrails in place that basically drop individual, traceable identifiers, and we only collect at high enough density so that it would be aggregated and anonymized. So, Greg, I don't know if you had any other notes on that that you wanted to touch on for the kind of privacy note there. Oh, the other thing is that it is Z18 is sort of the limit there, which is again sort of that city block basis. So you can't go into someone's individual house and look at like, okay, what does the activity look like for this particular home? And if there's, single family home, all of that data is going to get scrubbed. So it's not a full look at, the individual homes, just because we want to make sure that we're protecting privacy. So, but for any kind of like aggregation for a neighborhood scale, looking at the general activity of folks in a residential neighborhood, you'd be able to see that, but you're not gonna be able to see someone's house, because that's just, that could be abused, right? So we don't want to have that. Cool.
Yeah, all right. So thank you, Kieran and Megan, for walking us through those demos. I do want to say we have a few questions, so I will get to those. If you do have another question, please type it right into the Q&A. And you can also see a QR code here if you don't currently have a Mapbox account and you would like to get started with our mapping, get started with movement data, you can scan that QR code. I want to introduce someone else, Chris Byers, who's actually on this call, who some of these questions might actually be best suited for. Chris is really one who manages our movement product and our boundaries product, but Kieran and Megan, please feel free to jump in. So we did have a question. Is your data set an aggregation of wireless users from all carriers, or can it be broken down by carrier to see the service gaps in specific areas between two or more carriers?
Yeah, so the way that the Mapbox collects data is from our folks using our Maps SDKs or other SDKs on applications that they've built. So this usage that we get, the telemetry that comes back, is from basically all carriers across about 45,000 apps globally. So it would cover every single carrier basically that's providing data coverage in a particular area. We do not actually attach information about which carrier was providing that service at the time. So we couldn't really break it down by carrier, but you could use it as a bit of a differential on saying, here's our coverage and here's where movement data covers to create kind of an inverse map of what data coverage is available in a particular area from all other coverage.
Thank you. And I wanted to pass this next one on to Megan because it's very related and related to the coverage, identifying gaps and opportunities. So, Megan, you did kind of point to this, but what would be sort of the high level process of sort of like, can you overlay the movement data onto your existing coverage data? And how does that work?
Yeah, the activity index or the coverage on top of the coverage.
Yeah.
Yeah. So I mean, for the process of this, I took the activity index and I binned in the H3 grids, and because Mapbox gives you the flexibility to show your data on the map. You give us the data, we'll throw it on there. You can use coverage data. You can use like store locations, whatever location data you have, you're able to bring it to the map, and you can compare that to movement um, by using GLJS or any one of our SDKs, really, and you can simply add it as a layer on top. I chose to like weave in the activity index and the count in a vector tile. But let's say you're not working with Mapbox vector tiles today and you have like a GeoJSON separately, or you can add it at runtime. But we do recommend, for performance reasons, tiling the data, and you can do that with Mapbox. But yeah, I believe that answers your question, Greg. I don't know if anyone else has any color to add there. But...
Yeah, I would just say that there's a couple of different ways to bring the data to the map. It can also be used without the map. Like, I think that's something that customers ask about a lot too, is you can use the movement data as a data set and just use that in analysis without needing to visualize it. Obviously, we're biased towards visualizations on maps, so we're gonna maybe think that way, but you could do this like in some sort of data analysis tool and use the raw data as well. And we have a lot of customers that actually do that. But if you are working with the map or the movement data and want to bring that to the map experience, or you want help kind of getting started with that, our team and Megan especially has a lot of experience doing this, obviously with the demo. So we can show you kind of best practices, and feel free to reach out to us to get started. I really want to encourage anyone on the call that does have questions about movement data that, the team here can definitely assist in getting started.
Thanks, Kieran. And
Yeah,
just
and I will.
Oh, go ahead.
Oh, and I will highlight that in this demo, I'm in the browser is where I'm calculating the total sum of activity within the outages. But ideally, like while you're scaling out, like your coverage across the U.S. Or wherever you are, ideally it'd be something that you process in the backend. So that CSV format, or we have other data formats as well. Chris, I think maybe you can speak to that. But there are many ways you can integrate the movement data into your process, and you would calculate it for that outage and then put that on the map, or without a map, like you mentioned.
So I think
back to you
that
guys.
let's just get one last question, because we're bumping up against time, which I think that's sort of introduced. But Chris, how do you get access to the movement data? How is it delivered? Basically, how do you get started with it?
Sure. So if you go to the product page for this on the Mapbox website, there will be a little button that says Contact Sales. We can handle your request there and get you started with a trial of some data that's publicly available, or we can cut a custom trial for you for whatever area you're interested in. And then the license is an annual license basis. So there's not really a usage component on raw data necessarily. So we'll just license data based on which areas you need. And that's usually delivered as a CSV, as Megan mentioned. We are working on a raster format deliverable through raster tiles, but that's not quite out the door yet. And from there, we can work with you to get it delivered how you need it.
Awesome. Thank you so much. Yeah, I'm going to call it there because we are at time. So thank you everyone for joining us. I did leave just our contact information up here if you want to take a picture of it or jot it down. What Chris said, you could go to the link which Kieran actually provided in the chat, or you feel free to just message anyone on this slide directly. Be more than happy to help you. So with that, we really appreciate you taking the time to join us for this hour, and we know it's tough to take time out of your busy day, so we really appreciate it.